Hi guys, in this lesson we are going to continue practicing solving exponentials and logarithmic equations. All right, but before we get started, I want to show you something. So if I gave you the problem log of 100, and then I gave you the other problem of log of negative 100, and I said, give me those answers without a calculator. All right, remember, well, if I just write log, that means the common log. So you can pause the video and think about it and then press play, of course. But so common logs have a base 10. So basically this is saying 10 to the what power gets me 100? Well, we know that 10 to the second power gets us 100. So the answer there is 2. But then when I give you log of negative 100, is there any number that I can take 10 to the power of to get a negative 100? Now, some of you in your mind might be thinking, of course, it's negative 2. But we should know that 10 to the negative 2 is actually 1 over 100, right? So there is actually nothing that we can take 10 to get a negative number. There's no power that we can take it to get a negative number. So this is an example of there being no solution, or we could also think of an extraneous solution. And you might remember that word from Algebra 2. It happened for some of our different types of solving problems. So we're going to see some of those today. All right, so here's some quick reminders for you guys, and this is available on the note sheet for you. But you can, pause whenever you're ready and, press play whenever you're ready. So our steps for solving logarithmic equations, we're going to use the product or quotient property to combine logs if they have the same base. We'll use the power property to move coefficients to a power or divide both sides by that coefficient. And we'll use one-to-one and inverse properties to solve. All right, exponentials, similar process. All right, so we're going to use exponent rules first to combine exponents if they have the same base. All right, and then we're going to use one-to-one or inverse properties to finish solving. All right, so for one-to-one problems, you're going to have, the log equal to the log or the exponential equal to the exponential. Then you can use your one-to-one property to simplify and solve for x. For the inverse property, you're going to have log equal to a number or exponential equal to a number, and you'll have to use your inverse property to simplify and solve for x. So we're going to do some practice with both. So this first one is one-to-one, and we're going to solve for x. At any point in time, feel free to stop the video, try it yourself, and then press play when you're ready. So with this particular problem, we notice we have log base 5 of 4 plus log base 5 of x equals 3 log base 5 of 2. Because we see that plus sign in between, we should remember that that's our product property. So we can combine these by multiplying what's inside our log. So it's going to be log base 5 of 4x equals 3 log base 5 of 2. Now really, I could have also rewritten that other half, so I'm going to erase that for a moment. Okay, we notice this coefficient here, right? We can take that coefficient and make it the power rule, power property. So it becomes log base 5 of 2 to the third, but we know that 2 to the third is 8. So now we're here. Now we have a log equal to a log, so this is why it's one-to-one. So because our bases are the same, right, both are base 5, we know that 4x is equal to 8. Then we're going to divide both sides by 4 to get x equals 2. And if you're ever uncertain of yourself, you can always do a check, right? You could plug the 2 back into the x. All right, log base 5 of 4 plus log base 5 of 2 would become log base 5 of 8, right? Because product property allows us to multiply there. And we know that you put that on the power there, 2 cubed is 8, so log base 5 of 8 equals log base 5 of 8. So x equals 2 is our solution. All right, the next one, we got the natural log of 8x minus the natural log of 2 equals the natural log of 4. So you have to remember your properties, right? Notice that minus sign, that's quotient property. So we're going to have natural log of 8x over 2 equals the natural log of 4. Okay, now of course we should know that the natural log of 8x over 2 becomes the natural log of 4x. All right, and now we have a natural log equal to a natural log. Once again, one-to-one property says now I can set 4x equal to 4 and solve for x. So I would divide by 4 and I get x equals 1. And of course we could check and make sure that it works, and it absolutely will. For the next one, all right, this time we have some exponents, right? We have some exponentials, I should say. All right, so we're going to use our exponent rules because you might be saying, wait a minute, that's not a plus or a minus. I don't know what to do. Okay, so we're multiplying here. So remember, you keep your base, so keep our base of 2, and you add your coefficients. So x minus 1 plus 3x becomes 4x minus 1. On the other side, we're good to go. It's already 1 combined. So now again, we can use our one-to-one property, and we're going to set our exponents equal to one another. So 4x minus 1 equals 5x minus 7. We're going to subtract 4x from both sides, and then we're going to add 7 to both sides. So x equals 6. Again, we can check our work if we're uncertain. 6 times 4 is 24, minus 1 is 23. 5 times 4 is, whoops, hold on, I messed up my math there. Oh, 5 times 6, I apologize, is 30, minus 7 is 23. So we did the math right. Okay, so here is another one. This one is a little bit more challenging. So we've got 2 log base 6 of 4 minus 1/4 log base 6 of 16 equals log base 6 of x. So we might want to use our power rule first, our power property. So this would become log base 6 of 4 squared, which we should know is log base 6 of 16. All right, this 1/4, remember, if you've got 16 to the 1/4, that's actually the same as the 4th root of 16. All right, so that's going to be log base 6 of 2, because the 4th root of 16 is 2. And over here, we can keep log base 6 of x alone. Now we've got subtraction going on. That's the quotient property. So we're going to put those together. So log base 6 of 16 over 2, well, 16 divided by 2 is 8. Then we can set the 8 equal to x, and we are done. Okay, now let's move on to some examples with the inverse property. Okay, so if you look at this particular problem, you should notice the plus sign, so that's product property. So we're going to multiply x plus 2 times 3, make sure you're distributing, and that will get you 3x plus 6, and then that's equal to 4. Now, okay, we have to use our inverse property. So to get rid of the natural log, we have to take both sides, we have to put e to that power. So the e cancels the natural log, and we're left with 3x plus 6. Over here, we just have e to the 4th, and we can leave it like that. We really don't want a decimal for it. We want exact values. All right, so now we're going to solve for x. So subtract 6 from both sides. That gets us 3x equals e to the 4th minus 6. And then we're going to divide both sides by 3 to get x equals e to the 4th minus 6 over 3. Or you could also write that as 1/3 e to the 4th minus 2. Either answer is completely fine. All right, for the next one, okay, we have log base 2 of 4x plus 10 minus log base 2 of x plus 1 equals 3. So subtraction problem, so this is quotient rule, or quotient property. So I'm going to write it like this. So log base 2 of 4x plus 10, whoops, sorry, that moved on me, over x plus 1 equals 3. All right, now how do we get rid of a log? Well, you look at the base is 2, so you're going to take 2 to that power, 2 to that power. Okay, so this 2 and this log base 2 cancel, leaving me with what's inside of my base, or my log, I should say. So I'm going to have 4x plus 10 over x plus 1 equals, now 2 cubed is 8. Okay, and now again we can just solve it. This is a typical, algebra problem. So we would multiply both sides by x plus 1. Okay, and we're going to get 4x plus 10 equals 8 x plus 8. All right, so we would subtract 4x from both sides. We would also subtract 8 from both sides to get 2 equals 4x. And then divide both sides by, not 2, but 4. So we get x equals 1/2. And again, we can always go back and check our work, which is always a good idea. But I'm going to keep rocking and rolling so we can get through these last two examples. So we've got e to the 4x plus 3 over e to the 2x equals 12. Now you might be like, what in the world do I do here? But guys, good old quotient rule right here, right? You keep your base and you subtract your exponents. All right, so if we want to keep our base and we're going to subtract our exponents, so we want to do 4x plus 3 minus 2x. So we can only combine those. So that's going to become e to the 2x plus 3 equals 12. How do we get rid of e? Well, we take the natural log of it. Okay, so when we take the natural log of that, that goes away, and we're left with 2x plus 3 equals the natural log of 12. Okay, then just solve. Subtract 3, 2x equals natural log of 12 minus 3. Divide both sides by 2, and you get x equals the natural log of 12 minus 3 over 2. If you really want to write it another way, you can. You could write it as x equals 1/2 natural log of 12 minus 3/2. But either way is fine. All right, last problem here. So with this particular problem, you'll notice that we actually do need a check because there will be an extraneous solution. So we have log base 4 of x minus 3 plus log base 4 of x plus 3 equals 2. So again, we see the plus sign, so we know that's the product property. So we're going to multiply x minus 3 times x plus 3. Now remember, when you do x minus 3 times x plus 3, okay, you have to multiply it all out. So x times 3, negative 3 times x, and negative 3 times 3. So you'll end up getting log base 4 of x squared minus 9 because the middle terms actually end up canceling each other out. The other side is still just 2. Now to get rid of log base 4, we're going to do the fourth power here. So we'll end up with x squared minus 9 equals 4 squared. 4 squared is 16. All right, and to solve a quadratic, you should remember from Algebra 2, all right, we're going to subtract 16. We want to get it equal to 0 so that we can solve by factoring. Or really, with this particular one, you could solve by square root method too. So you could do either square root method or factoring. But this is a pretty easy factoring problem, right? It's going to be x plus 5, x minus 5, since it's the difference of squares, which means that x equals negative 5 or positive 5. Now this is where we have to check. So if you go back and you plugged in negative 5 into this problem, all right, you'd end up getting log base 4, and then you'd have negative 5 minus 3, which is negative 8. And you'd also have negative 5 plus 3, which is negative 2. And you should remember, you can't take the log of a negative number. There's no 4 to any power that's going to get you a negative number. So this is extraneous. So whenever you take the log of a negative number, it's going to end up being extraneous, all right, unless the expression allows that number to eventually become positive when you take it. All right, so the correct answer and the only answer is 5. All right, so bring your questions to class and we're going to practice some more.